Welcome back, Focus Learners. Today we are opening up what I absolutely love to call the legal brief. We're taking an exclusive, behind-the-scenes look right into the Cambridge Examiner's playbook. Whether you are tackling syllabus codes 0580, 0606, 4024, 4037, 4040, or stepping up to the advanced 9231 and 9709 papers, the strategy we're breaking down today is going to change everything. We are specifically focusing on a topic from the AS and A-Level Mathematics 9709 syllabus that honestly haunts a lot of students, but it absolutely shouldn't: the conservation of linear momentum in direct impact. Listen, think of this explainer as your ultimate courtroom preparation. You aren't just a mathematics student today, okay? You are a top-tier barrister. Your exam paper is your active case, your working out is your hard evidence, your logical steps form your argument, and your final answer? Well, that is your undeniable conclusion. To really understand how to build a bulletproof case, let's look at two typical students. Let's call them Alex and Sam. When Alex sees a momentum question, he completely overloads his answer with raw mathematical facts, just scattered numbers everywhere, providing absolutely no structured direction or analysis. It's a data dump. Sam, on the other hand, sees the exam timer ticking down, completely panics, rushes through the problem, and entirely misses the specific command word requirements. Both of these approaches result in heavy red pen marks all over their papers, despite the fact that, crazily enough, they both actually know the underlying physics. Our mission today is to completely transform those red marks into green check marks. Let's dive in.
So here's our game plan for today's session. Number 1, the momentum mandate. Number 2, the procedural framework. Number 3, the method mark strategy. And finally, number 4, critical examiner warnings. By the end of these 4 steps, you'll know exactly how to secure those top marks.
All right, Section 1, the momentum mandate. Let's set the stakes for why mastering this specific topic is completely non-negotiable.
The conservation of linear momentum in direct impact is not just some standalone optional concept, it is a foundational pillar of mechanics. It tests your ability to model real-world physical situations using abstract mathematical equations. When an examiner looks at your answer here, they're getting a diagnostic snapshot of your entire mathematical competence. Just look at this direct quote from the senior examiner's notes. It says, "Mastering momentum is essential for success. This topic appears in every examination series." Let that sink in for a second. Every single series. Knowing this gives you a massive tactical advantage, right? You know the opponent is coming, so you can build the absolute perfect defense. Before we continue and show you exactly how to build that defense, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, notice how the syllabus actually defines this topic. It doesn't just say, hey, know the formula. No, it explicitly demands a fundamental principle requiring connected conceptual understanding transferable to unfamiliar contexts. This is exactly where our friend Alex completely fails. Remember Alex? He just memorizes the formula and tries to blindly plug numbers in. But examiners are sneaky. They actively design questions to be set in completely unfamiliar contexts. Maybe it's particles colliding on an inclined plane, or a really complex series of 3 spheres impacting sequentially. Top-performing students don't just memorize, they build cross-topic connections. They understand that momentum connects to kinematics, to energy conservation, to Newton's laws. You literally need to conceptually visualize the event in your mind's eye. 2 bodies interacting for a split second, exchanging momentum, while the total system momentum remains perfectly, beautifully constant. That deep transferable understanding, that is exactly what the examiner is desperately searching for in your working.
Moving on to Section 2, the procedural framework. This is where we transition into the technical methodology that separates the average student from the top-tier candidate.
Having that conceptual understanding is great. It's the foundation. But how do you actually translate that onto the exam paper when you're under immense time pressure? You need a standardized system. You need an autopilot. Let's walk through this mathematical blueprint. Step 1, identify given info. This means drawing a large, crystal-clear diagram. You define your positive direction explicitly, literally draw an arrow with a plus sign next to it. You list the masses and velocities, and you have to be ruthlessly strict with your negative signs. Step 2, apply principles. State the principle you are using out loud on the paper. Actually write the words by conservation of linear momentum. This signals to the examiner that you know the legal framework of your case. Step 3, execute clear working. Now this is where you apply the Peel framework. That stands for point, evidence, explanation, link. Your point is the core formula. Your evidence is the substitution of your specific values. Your explanation is your line-by-line algebraic simplification. And your link connects the final math back to the physical reality of the question. Finally, step 4, verify results. Take a step back. Does the final velocity actually make physical sense? Did a massively heavy object suddenly bounce back at the speed of light? If so, guess what? You dropped a negative sign. Treating mathematics like this procedural framework prevents total cognitive overload during the exam.
And this framework only comes to life on the page through really strict conventions. The syllabus specifically notes that presentation of information requires proper headings, correct terminology, appropriate formats, and clear annotation. Now, you might be sitting there thinking, well, as long as I get the right answer at the bottom, who cares if the working's messy? The examiner cares. Presentation isn't just about neatness. These conventions are professional skills required by the syllabus to secure maximum points. When you clearly annotate your before and after states in a direct impact collision, you are handing the court undeniable evidence. When you use correct terminology, like distinguishing between speed, which is a scalar, and velocity, which is a vector, you prove your absolute mastery. If you write 5 meters per second without indicating the direction when the command word specifically asks for velocity, you lose the mark. And this is exactly what our other student Sam does constantly. He rushes to the number 5, completely ignores the command word velocity, forgets the directional format, and just bleeds easy marks all over the page.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into Section 3, the method mark strategy. This is the critical evaluation phase.
Listen closely, because examiners don't just sprinkle points randomly across your paper. They award marks based on very specific, demonstrated assessment objectives. Let's decode them. For knowledge and understanding, top candidates don't just state a basic formula. They actively reference cross-topic connections. They might recognize that right after the direct impact, the particle travels under constant deceleration, instantly linking momentum back to kinematics. For application, the required action is to solve systematically. This means taking that Peel framework we just talked about and showing the clear, undeniable substitution of values into the momentum equation before you attempt any mental arithmetic. And for analysis, especially in those daunting, high-mark questions, you have to justify your recommendations or conclusions. If the question asks whether a second collision will occur down the line, you must analytically prove it by comparing the new velocities. You are essentially writing a mathematical essay. Your numbers are your vocabulary, and your algebraic steps are your grammar. Every single line of working is a golden opportunity to pick up a method mark.
Okay, we're going to run a quick interactive workshop right now. I want you to really focus. In higher order questions, you are often asked to perform critical analysis of a given model. True comparative analysis requires identifying both similarities and differences. So, challenge 1, data scan. Imagine a complex momentum data chart pops up on your screen. It shows the velocities of 2 particles before and after an impact. You have a 60-second mental countdown ticking away to extract the core trend and compare this experimental data with theoretical calculations. You cannot just write, "they are different." That gets you nowhere. Challenge 2, find the flaw. You have to use specific comparative connectives. A top-tier answer looks like this. While the theoretical model assumes perfectly smooth spheres resulting in a final velocity of v, the experimental data shows a velocity of 0.9 v, suggesting the presence of external frictional forces. Boom! You see what happened there? You linked the mathematical evidence directly to the real-world physics. You extracted the trend, found the flaw in the simplified model, and used your analytical framework to bridge the gap. That is exactly how you secure those final, incredibly elusive marks.
Which brings us to perhaps the most urgent examiner alert of this entire explainer. Look at this. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. This is your ultimate lifeline. Let's go back to Alex for a second. Alex does 3 lines of complex algebra in his head because he thinks he's a genius, writes down the final velocity, but he made a tiny, silly arithmetic error along the way. The result? 0 marks. Nothing. He provided the court with 0 evidence for his case. The examiner cannot see into your brain. They can only grade the ink on the paper. So here is challenge 3, speed writing. Next time you practice, give yourself 30 seconds to write just 1 perfect Peel paragraph. If you explicitly write out the conservation of momentum equation, point, then explicitly write out the substitution step, showing your masses and velocities, evidence, you have instantly secured the M1 method mark. Even if you completely mess up the final calculation, that method mark saves you. The process is just as vital as the final conclusion.
Finally, Section 4, critical examiner warnings. Let's shift our focus to prevention by learning from actual mistakes.
We've talked a lot about what you should do, but now we need to look at the autopsy reports. We're talking about the actual principal examiner reports from past Cambridge papers to see exactly where students are just throwing their grades out the window.
So I want to pose this provocative question to you right now. Why do students lose easy marks? Really think about it. These are students who have studied for months. They know the formulas, they understand the concepts, yet they walk out of the exam hall with a B or a C instead of an A. Why? The examiners compile data on this every single year, and the answers are shockingly consistent. It almost never comes down to a lack of deep mathematical genius. It comes down to a total failure of execution and a lack of situational awareness under pressure.
Let's deconstruct the top 3 critical errors directly from those examiner reports. Number 1, improper format. This goes straight back to decoding command words. If the question asks for velocity, and you just slap down a positive number without defining the direction of motion, your format is improper. Velocity is a vector. Number 2, poor presentation. Students draw these tiny, cramped, completely illegible diagrams where the examiner literally cannot tell which arrow belongs to which particle or if an arrow is pointing left or right. Remember the barrister metaphor? If your evidence is a mess, the judge throws the case out. Number 3, answers lack specific context. Failing to contextualize your mathematical answer absolutely destroys your grade. Let's say you calculate that v equals -3 meters per second. You cannot just leave it hanging there. You must explicitly state what that negative sign actually means in the context of the problem. You need to write, therefore, particle A reverses its original direction of motion and moves at 3 meters per second. You have to translate the abstract algebra back into the physical reality of the impact.
To help you avoid every single one of these pitfalls, I'm going to give you a brilliant memory hack from the source material. It's a key part of our mathematics success blueprint. We're going to create a mnemonic using the first letters of key momentum terms. Let's use the word impact. I stands for identify the positive direction. M is for masses and initial velocities listed clearly. P means principle of conservation of momentum stated out loud. A is for apply the formula with your substitutions shown as evidence. C stands for check your negative signs carefully, and T is for translate your final answer back into the physical context. Write impact at the very top of your page the second you see a momentum question. It forces you to follow the procedural framework, and it guarantees you capture every single method mark available. We have built an absolutely airtight case today. We've decoded the command words, we've applied the Peel framework, and we've mastered the time management matrix by knowing exactly where the marks are hidden. A top barrister never goes into court unprepared, and now neither will you. But consider this, the conservation of momentum isn't just some boring rule on a piece of paper. It is a fundamental law governing the entire universe, from 2 billiard balls colliding on a table to massive stars colliding in deep space. If the universe meticulously tracks every single transfer of energy and momentum to absolute perfection, shouldn't you do the exact same thing on your exam paper? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.